Question 11. This question requires a lot of analysis. So let's jump right in. And I'll take you through to analyze the whole diagram. The diagram shows a semicircle, so that tells me it's half a circle, exactly, with center O, radius R. And AB is the diameter. Then this is the center of the circle, this is the diameter, so this must be the radius. So they've labeled, radius R. AB, diameter, OBC. Okay, now angle OBC is pi over 3. Every time they give you an angle in pi, it means this must be in radians. Every single time. If they tell you angle is in pi, then this must be, if I'm just going to label it here, it must be in radians. If it's in degrees, then you will see the little degree unit. If there's no degree unit, then it's in radians. Or if they give you in pi, it's in radians. An angle AOC is alpha, so let's call this alpha, or they've called it alpha. And BOC is beta. So these are just, it's like x and y, they're just variables, unknowns. Find the ratio of each of the following. Alpha is to beta. So right off the bat, immediately it's hard to see how they're related, but we need to analyze the diagram first. So what can we see? Okay, we see that we know this angle. In fact, that's probably the only thing that we know in terms of numbers. Because this is R, we don't know the number. We don't know the number. But hey, what can you tell me about this triangle? If this is from the center of the circle to the circumference, then this is R, this is the radius. How about from here to here? This is also from the center of the circle to the circumference, so it's also R, right? And so if both sides R and R, then this must be an isosceles triangle. You may say, hey, this looks like it's R, but we don't know. We actually don't know. So you can't say this is R, but you can say that at least this is R, it's from the center all the way out. So if that is an isosceles triangle, then this angle must also be pi over 3. And so beta must therefore be, so let's solve for beta. So once again, 180 degrees is pi radians, and we know that a triangle, they all add up, all the angles add up to 180 degrees. So what I would do is, since that is pi radians, I would say, okay, beta must be pi radians. Subtract away this angle, subtract away this angle, and it also gives me pi over 3. Wow, so actually all the angles are the same. So actually it does tell me that yes, this triangle, since all angles are the same, it is an equilateral triangle. Yep. Okay, and then if we found beta, now let's find alpha. And so we say that angles, this is a straight line, right? So that would be 180 degrees. And we know that 180 degrees does convert to pi radians. So alpha basically is my 180 degrees or pi radians. And I subtract away pi over 3, which is beta. And this gives me 2 pi over 3. So this really is 2 pi over 3 radians. Cool. And so when the question asks for alpha is to beta, what we can do then, we can just say alpha, maybe let me do it here. Alpha is to beta is simply 2 pi over 3 is to pi over 3. And you can see that you can divide both sides by pi, multiply both sides by 3, and what you get is 2 is to 1. Okay, so now part double I, area of sector AOC is to area of sector BOC. So we can see that AOC, the sector is this, and BOC, this is the sector. Okay, and we want to find the areas and we want to compare them. So what we can do, since we already found the alpha and beta angles, it really does help So we can say for AOC, it's half theta r, and do we know what r is? We don't, but it's okay. Let's just put it like this. And for sector BOC, we can say it's the area is half pi over 3 r square. And when we want to take the ratio of the areas, we then just do this. And what you notice is that the r squares cancel out, the halves also cancel out, and the pi's also cancel out, and you can also multiply both sides by 3, and the answer is also 2:1. Okay, part III, area of triangle AOC to area of triangle BOC. And so this one is slightly different. AOC, the triangle is actually here. And for BOC, the triangle is here. And what do we notice? We notice that they actually have the same height, right? Like this is actually the height. So that's cool, because if that is the height, then we can see that the area of a triangle is half times base times height. And so we have the same height. Do they have the same bases? Oh yes, they do. They actually do, right? This triangle here, the base is r, and this triangle here, the base is also r. So they also have the same bases, right? So that tells me that the ratio is 1:1 because they have the same areas. They're the same areas because they have the same bases, which is r, and the same height, which I've shown you, the yellow line. So the ratio 1:1. Part B. Find the value of r if the area of sector AOC is 12 pi cm square. So we go back to area of sector AOC, this sector, and we've actually found the formula to find the area of sector AOC, and they're just saying now that this is equal to 12 pi. So let's just copy it down. So they're trying to say that this is equal to 12 pi. Find the value of r. Can we find r? Yes. Right, this is r, and the rest are all numbers. The pi's do cancel, and so I can multiply the half in, and the 2's do cancel. So this r squared over 3 equals to 12. R squared equals to 36. And therefore, r equals to square root 36. Length cannot be negative, so we just leave it. Equals to 6 cm. Yep. There you go.